Okay, today we're going to discuss friction in fluids. First off, before we go any further, let's define what a fluid is when we're discussing this in our class this year. A fluid is any substance that can flow easily, and that's going to include gases and liquids. Okay, so fluids include gases and liquids. Okay, so if you want to think about it for your own purposes, I would refer to air when we think about gases and water when we talk about liquids. Okay, but they're both considered fluids. Okay. Now, when an object falls through a fluid, they hit the molecules of that fluid. So whether it's air or water, let's imagine that we have some air or water molecules, or fluid molecules, we'll call it. Okay, so if this is our fluid molecules, and we dropped an object, all right, into that fluid, all right, that object is going to hit the molecules. Okay, so as the object falls, it hits into more and more fluid molecules. And according to Newton's third law, every action has an equal and opposite reaction. So while the molecules may not be as massive as the object, okay, they are still hitting back with as much force as that object is hitting them. So there's going to be some resistance there, and that's going to lead into what we talk about as air resistance or water resistance. Okay, so as the object falls, it pushes against the molecules. As it gains speed, as it falls faster and faster due to gravity, it's going to hit more and more molecules. All right? So when we talk about an object moving through a fluid, okay, surface area is going to affect friction. The more surface area, the more friction, because it hits more molecules. Okay, this is different from sliding friction. Surface area has nothing to do with, well, I shouldn't say nothing to, but surface area doesn't affect sliding friction when you talk about two objects coming in contact with each other. But when we talk about fluid friction, it does. Think about when you stick your hand out the window of a car. All right, so if you stick your hand out while you're moving, you probably found that if you turn your hand flat, you feel the wind push your hand back. But if you turn it on its side, almost like, you'll find that it cuts through those fluid molecules more easily. So for instance, if we had fluid molecules here, okay, and we had a sharp edge, like the tip of a jet or something like that, cutting through the fluid molecules, it comes in contact with much fewer molecules. So the resistance, the fighting back, the Newton's third law, is reduced. So not as many molecules are pushing back on the surface of the object. All right, over here you see, you would, like, let's just, in this example, you would have 1, 2, 3, 4, 5, 6, 7 molecules pushing back on that block. Here you would only have 2 molecules for every layer of fluid. Okay, so the less surface area when we talk about fluids equals less friction. Okay, so just to recap, as an object falls, it's going to hit molecules, or moves through a fluid, I should say. It doesn't necessarily fall, it could be moving left to right. So as an object moves through a fluid, it hits molecules. The faster it moves, the more molecules it hits. Faster motion, more molecules, are hit, which leads to greater friction. Okay? Now, when we talk about hitting those molecules in the air, or we could be even say water. But if something's falling through the air, it's going to meet resistance of the molecules. So like we said, the faster it falls, the more molecules it hits. Now, as an object falls, okay, it's going to gain speed. It's going to get faster and faster and faster until it's hitting so many molecules per second that the molecules are hitting back rapidly enough to balance out the rate at which it's falling. And that's what we call that's when an object reaches its terminal velocity. Okay? So when an object falls, it's going to fall so fast that it hits so many molecules that the amount of molecules actually balance out the force pushing down, so it stops gaining speed and it maintains its velocity at that point. So it'll still be moving very fast, but it will not be gaining, it will not be accelerating anymore towards the Earth. And that only occurs when you have an atmosphere where you would have fluid molecules such as air. So air resistance is affected by two things. Okay? Surface area, because the greater surface area, the more molecules it hits, and speed. Because the faster you go, the more molecules you come in contact with. You're hitting them more rapidly. Okay? So the more surface area, the more air resistance. So the greater the surface area, the greater resistance. The greater the speed, the greater the resistance. Okay? So just remember that the greater the surface area, the more surface there is for molecules to hit, and the greater the speed, the more molecules it hits as it falls. Okay? To recap, when we talk about air resistance or fluid friction, we're talking about the greater number of molecules you come in contact with is where Newton's third law comes into play, where you have an action of an object moving through a fluid and the reaction of the molecules hitting back against it in the opposite direction. Okay? The greater your speed is, the more molecules you're going to come in contact in within per second as you fall. So the more molecules you come in contact with every second, the more resistance there is. Okay? That's it for today. If you have any questions, please feel free to ask us as you work on your task list. We'll be here for you if you have any questions regarding air resistance and fluid friction. All right? We'll see you tomorrow.